Hello everyone, welcome to DhiNexus. This is Surya. Today we are going to learn about number system, real numbers. At DhiNexus we make learning simple, engaging and clear. So stay tuned till the end of the session. So when you talk about number system, what are these real numbers? So numbers, when I say this to you, what comes into your mind? It can be a natural number, whole number. Rather than a natural number, whole number, other numbers are there. Let me show you one by one. So, as I told you, natural numbers starting from 1, whereas whole numbers we start from 0. So, we use letters to note that whole numbers. Whole numbers can be represented by W, right? So as shown here, see natural number starting from 1, we denote that by N. And whereas whole numbers starting from 0, we denote by saying W. Then what are these real numbers? Nothing but set of natural numbers, whole numbers, integers, rational and irrational numbers. So you know already about natural numbers and whole numbers. And what are these integers, rational and irrational numbers? Okay. See, integers are like to remember about integers, I can say you can refer a number line. So in a number line, we write negative numbers, positive numbers, 0. 0 is neither positive nor negative. We know that. So set of positive integers, negative integers, those are called integers. That is denoted by Z. Okay. Then what is a rational number and irrational number? Okay. See, we usually represent fraction by a numerator and a denominator, right? So all those number, whichever can be expressed in the form of fraction, like P over Q. P and Q are any integers. It can be positive integers or negative integers. But there must be one condition under Q is not equal to 0. See, for example, we can say 3 by 5 minus 2 by 3 minus 3 by 4 are called rational numbers. Simply, whatever number can be expressed in the form of a simple fraction, we say that one as a rational numbers. So, in other case, what we do if we cannot express into a fraction, like square root of 2, square root of 3, square root of 5, like this, we say irrational numbers. Okay, let me explain you in detail. See, I told you number can be expressed as a fraction. Let's take letter P over Q. So those are integers and can be expressed as a fraction. I said rational numbers. Yeah. Now, talking about irrational numbers cannot be expressed. For example, we say pi. So what is the value of pi? 3.14. So here I gave you as an example of a decimal, right? Okay, expressing decimal, recurring, non-recurring, whether we can terminate, we cannot terminate in certain conditions. So all these irrational numbers are here. Okay. Now, one more thing is there. When we use the term square root within a number, we assume that must be a positive square root, but it's not like that. Often minus 2 also be there. How? See, square root of 4 is 2. And what is square root of can be expressed as negative 2? As like minus 2, the whole square would be also 4, which is equal to square root of 16, right? Okay, I gave you these examples to tell you about. There are infinitely many rational numbers, irrational numbers between two numbers. Okay. And what is this equal and rational numbers? Okay, in fractions before during at primary level, you might have learned about this equivalent fraction, right? Same. See, whatever the fraction, it is 1 by 2, 2 by 4, 12 by 24. These are called equivalent fractions as well, equivalent rational numbers. Okay, in the form of P over Q. Now, see, I hope this classification will helps you to know details more clear. See, I have inserted a circle inside natural numbers, outside whole numbers. See, 8 by 2, a fraction, also considered as a rational number. Square root of 9 is a perfect square, right? Square root of 9 is 3. Also a rational number. And outside, as you can see, these are all rational numbers. Okay, what about irrational numbers? So cannot be written as a fraction. Okay. You might ask one thing. You told me decimal numbers is an irrational one, but given here is 0.97, 0.21. These two terms, why you have included into rational numbers. See, I have denoted a line segment above to 1. It's recurring. A recurring means it could be 2, 1, 2, 1, 2, 1, like that it goes on. What about 0.97 then? See, 0.97 um, you can find whole. I mean, when round off, we can say 1 accurately. So these are all some terms where we can write as a rational number. Okay. Let's talk about rationalizing denominator. This is very important here. When denominator is irrational, keep this thing noted. What is that denominator thing irrational? See, for example, I have given you 1 over root of 2, square root of 2 plus 3. In denominator, can you say square root of 2 plus 3 as rational number? No, you cannot say. So, when you have like these kind of situation, what to do? We can rationalize the denominator. There is such a solution there. How to start? Just the condition is multiply by the denominator. What is given in denominator? Square root 2 plus 3. Change the sign in between. If it is square root 2 plus 3, you write square root 2 minus 3. And you multiply the same above and below by the denominator and numerator as well. As you can see, the given example is 1 by square root of 2 plus 3. And I have multiplied square root of 2 minus 3, taking the opposite sign of the sign between the two terms under denominator. See, since 2 square root of 2 plus 3, I have taken square root of 2 minus 3. If it is square root of 2 minus 3, I would be taking square root of 2 plus 3. I hope this is clear. Now, let's get into this simplifying, evaluating. Now I got 1 times square root of 2 minus 3, same. See, we have square root of 2 plus 3, square root of 2 minus 3. When you multiply both, can you find it is relevant to a plus b times a minus b, which is a square minus b square. I have used that formula here. So a is square root of 2, b is nothing but 3. So I have implemented a square minus b square, which is nothing but a square, a plus b into a minus b. Square root of 2, the whole square would be 2 and 3 square would be 9. So I got square root of 2 minus 3 by minus 7. See, minus 7 is a negative integer. It's a rational number, not an irrational number. Thus, we have converted the irrational denominator by rational denominator by the term rationalizing denominator. I hope this video will be helpful for you to learn about this topic and you will be liking it. So don't forget to like it and share it to your friends. And of course, don't forget to subscribe DhiNexus. Okay, now let's start some practicing exercises in this real numbers of number system. I'll show you an example of that. So let's practice some questions in this number system about real numbers. Like I have shown here, have taken some questions with basic, medium, and advanced levels. Let me do one by one. Okay. See, first given here is simplify the following. To start this before, you should know we can simplify. I mean add, subtract. You can add, subtract, multiply, and divide operators inside this expressions. Okay. Okay, let me do the first one. Now, simplify the following. Just given 4 square root of 3 minus 2 square root of 2 times 3 root of 2 plus 4 root of 3. Okay. Now I'm going to take this here. Question 1. Minus 2 square root of 2 within brackets, and here 3 root of 2 plus 4 root of 3. Okay. Now, can you see these two terms looking like distributive law? We use A plus B into A as A times A plus A times B. The same way, we are going to expand using distributive law. Okay, what we are going to do here, expand using distributive law. Okay, let me show you how. I'm taking the first term, 4 root 3 multiplied by 3 root 2. 4 root 3 times 3 root 2. And again this 4 root 3 by 4 root 3. See, both have positive sign. I'm writing the positive sign. 4 root 3 times 4 root 3 within bracket. Now, minus 2 root 2 times 3 root 2. And here, since it minus into plus, again minus 2 root 2 times 4 root 3. Okay. Now, let me write this. See, I have just expanded. So, if you put brackets inside, it will be confusing. So, you write this alone. Minus 2 root 2 times 3 root 2 minus 2 root 2 times 4 root 3. Okay. Now, whenever we do like terms like this, we often do grouping like terms. What do we say that call? Grouping like terms. Consider these dots as times. Let me multiply first. 4 times 3, 12. Root 3 times root 2, root 6. Plus 4 times 4, 16. Root 3 times root 3, 3. Right? So whenever you multiply 2 square, I mean square root of 3 times square root of 3 would be 3. Minus 2 times 3, 6. Times square root of 2 times square root of 2, 2. Minus 4 times 2, 8. Square root 2 times square root 3, square root of 6. Okay. Now 12 root 6 plus 16 times 3 would be 6 times 3, 18. 1 times 3, 48. Minus 12 minus 8 root 6. Now we got this root 6 together. We can group like terms, right? 12 minus 8 would be 4 root 6. And what is this? 48 minus 12, 36. So this is the final answer for this first one. Okay. I hope this is very clear. Let me take you to the second one. See, when we practice more, these terms will come very easier. Let me take you to the second sum. 2 plus square root 3 times 3 plus square root of 5. So again, I'm going to use distributive law to expand these both. I'm just taking 2 and multiplying 2 times 3 plus, see, 2 times 3 plus 2 times root 5. Here, root 3 times 3, both have plus sign, 3 root 3. Again, root 3 times root 5 plus root 15. Okay, now 6 plus root 2 root 5 plus 3 root 3 plus square root of 15. Okay, is there any like terms to um, group? I mean to add together? No, here it's a different term. Here is also a different term. Here is also a different term. Let it be as it is. This is the answer for the second question. Okay, let me do question 3. Now, in question number 3, we have square root of 3 plus square root of 2, the whole square. Can we compare with an algebraic formula a plus b, the whole square equals a square plus 2ab plus b square? See, as you can compare the expression, I can write a as square root of 3 and b as square root of 2. I'm going to simply substitute instead of a square root of 3 and instead of b square root of 2. Now square root of 3 plus square root of 2 the whole square would be a square, which is square root of 3 the whole square plus 2 times root 3 times root 2 plus b square, like this. Now square root of 3 the whole square would be 3 plus, see, root 3 times root 3 would be root 3 times 3, which is 3. Likewise, when you have like this, root of 3 times root of 3, which is the same. So that I have written, instead of square root of 3 the whole square, 3 plus 2 times square root of 3 times square root of 3, 2 would be root of 6 plus 2. Now I can group the like terms, right? We got 3 and we got 2 root 6 plus 2. I have written that 3 again here. Let me check again. See, square root of 3 the whole square is 3 plus 2 root 6 plus 2. Yes, now I'm correct. Now we got 3 and 2. We can add that. So final answer would be 5 plus 2 root 6. I hope this is very clear. And can we move on to the third sum now? Just we now finished third sum. So we need to move on fourth sum. So in the simplification, as I told you before, I have taken easy, medium, complex, difficult, so that you can learn everything inside my explanation. Okay, let's do question number 4. So as you can see, I'm just writing the question as it is. This whole term plus, without bracket, I'm just writing 1 by 3 root 7 plus 3 by 2 root 2 minus square root of 11. As you can see, you can group like terms here. See, 2 by 3, 1 by 3. What is 2 by 3 plus 1 by 3? Yeah, right. 3 by 3. So common denominator, you can add those numerator. Root 7, root 7. Here is a root 2 and here is a root 2 as well. 1 by 2 plus 3 by 2. See, you have minus 1 by 2 here. So that would be 3 by 2 minus 1 by 2, which is 2 by 2. I can write plus 2 by 2 square root of 2. See, the remaining 6 square root of 11 minus square root of 11. So 6 minus 1, 5 square root of 11. As you can cancel these, I can write square root of 7 square root of 2 plus 5 root of 11. I think this is more clear. So here I have shown you how to simplify using operators add, addition, subtract, multiply. Here. Okay, let me take you to the most important thing in this real numbers, how to rationalize the denominator. I have shown you a simple example before. Let me take you deeply into sums. How do we practice sums using that same concept? Okay. Now, we are going to start rationalizing denominator one by one. In this 2, 1, I'm going to take 2 over square root of 3 minus square root of 5. See, I have told you already. In denominator, if you have any irrational number, we can rationalize the denominator by following a method. We should follow a rule. What is that rule? Multiply that rational denominator by changing the sign inside. Let me repeat again. You should multiply the same, just changing the opposite sign by both numerator as well as denominator. I hope this is very clear. Now, after this step, whatever we have done before, the same would be following here. See, let me show you. 2 times square root of 3 plus square root of 5 over. See, can you see a plus b into a minus b equals a square minus b square format? Yes, of course, you're right. So, you consider a as square root of 3, b as square root of 5. I can write square root of 3, the whole square, minus square root of 5, the whole square. That is a plus b. This is a minus b, a plus b, right? I'm just multiplying the 2 inside, expanding. 2 root 3 plus 2 root 5 by a square minus b square, right? So we have 2 root 3 plus 2 root 5 are different terms. If we see same terms, like terms, we can add, but we cannot add here. Let it be as it is. Now, what is square root of 3, the whole square? I have told you this before itself. You can simply write 3 minus this term 5. No, now plus 2 root 5 by minus 2. This is the final answer. Okay. Let me do the second one. So in number 2, I'm going to show you the second one. Square root of 3 plus square root of 2 over square root of 3 minus square root of 2. So just you multiply by the same denominator by numerator and denominator after changing the sign. This is why we are doing here, to rationalize the denominator. Oh. Plus whole square over minus. Okay. Now the first one you can relate with this. A plus b the whole square is nothing but a square plus 2ab plus b square. Now we got square root of 3 plus square root of 2 the whole square, which is a square is square root of 3 square plus 2 times a times b plus b square is square root of 2 the whole square. We can simplify further. 3 plus 2 root 6 plus 2. Now I can write instead of this whole term as 3 plus 2 root 6 plus 2 by this is a square minus b square, which is 3 minus 2. I can write 5 as 3 plus 2 is 5, remaining 2 root of 6. This 3 minus 2 is 1. We can simply end here. See how easy it is, right? Okay. Let me do question 3 in this 2. So 6 by square root of 5 plus square root of 2 times, I'm just changing the sign, multiplying the denominator. I got this, right? Now, what when I'm expanding this over 5 minus 2, which is 3, right? And as you can see, let it be that 6 there, so that we can write 2 root 5 minus 2 root 2 as the final answer. Okay. So you can continue the same for these remaining sums. So let me take you to rationalize the denominator of the following here. Question 3. Before this, let me check one more time. See, I have done until this 6 by square root of 5 plus square root of 2. I can do one more. This kind I didn't teach, so I can do this one. And also this. So let me do first into 4. 1 by 8 plus 5 root 2, right? So I'll be doing like this, right? Now 1 times that's the whole thing would be the same. And this would be 8 square minus 5 root 2 the whole square. As a plus b into a minus b is a square minus b square. Now 8 minus 5 root 2 by 64 minus 5 square. The reason why I have chosen this sum is to show you this. See, include the square inside. 5 square separately. Now 5 square is 25. Square root of 2 the whole square is 2. I got 50. Is that clear? So 8 square minus 5 the whole root square. Root 2 the square will be 50. Now I can write 64 minus 50 would be 14. Right, that's all. I hope you understand this. Okay, quickly, let me do number 5 and let me finish this. Okay, number 5. 3 minus 2 root 2 by 3 plus 2 root 2. The same step. Multiplying the denominator by changing the sign above and below by the numerator and denominator. Now, I'm just multiplying numerator by a numerator and denominator by a denominator. See, you got 2, 3 minus 2 root 2 here and the same 3 minus 2 root 2 here as well. So, I can simply write 3 minus 2 the root to the whole square. This is a plus b, a minus b. So I can write a plus b into a minus b as what? A square minus b square. A is nothing but 3, b is 2 root 2. So a square is 3 square minus b square is 2 root 2 the whole square. Now, this is in the format 3 minus 2 root 2 the whole square is a minus b the whole square. Let me show you the formula. A square minus 2ab plus b square, right? A is 3, b is 2 root 2. Now 3 square minus 2 times 3 times 2 root 2 plus b square is 2 root 2 the whole square. Now I got 9 minus 2 times 3 times 2 would be 12 root 2 plus here, as I told you already, 2 root 2 the whole square would be 2 square times root 2 the square. So it should be 4 times 2, 8. So what is the term here? 8. 9 minus 9 plus 8 is 17 minus 12 root 2. I can write the whole term 3 minus 2 the root 2 the whole square as 17 minus 12 root 2 over a square is 9 minus 2 root 2 the whole square is 8. Am I right? Okay. Now I got 17 minus 12 root 2 since 9 minus 8 is 1. Okay. I hope you have understood the rationalizing denominator topic. Now let me do with some more sums like which is different from the above. See, you can find similarity this sum and this sum. So no need to do this. And here this one and this one. But I didn't teach here this sum. So I'll choose 6 to do this. And then what else I can do? This is this sum I need to do this sum, and this sum. So except 3 I need to do everything. Okay, let me take you to the first sum. This is third, rationalizing the denominator, but given like a only irrational denominator without operations. Okay, 2 by 3 root 3. In this case, what will you do at the next step? What is the irrational number given here? Root 3. Take that alone. No need to change the sign. When you have two terms inside any sign, you will be changing the sign, appropriate sign for plus minus, for minus plus. But in this case, it's simply 3 root 3, not any operators after this. So I am taking simply the rational number multiplying by numerator and denominator. Now I got 2 root 3 by 3 times root 3 times root 3 is 3. So that is one more 3 is here. 3 times 3, which is 2 root 3 by 9. That's all. So number 2, 16 by root of 41 minus 5. Sorry, root of 41 is only for 41, not 5. Okay. Here, what we have followed earlier, that thing, root of 41 plus 5 by root of 41 plus 5. So 16 times 41 plus 5 over a plus b into a minus b, a square minus b square. 16 square root of 41 plus 5 is nothing but 16 square root of 41 plus 16 times 5 over square root of 41 the whole square 41 minus 25. Now what is 16 times 5? 80 by 41 minus 25 would be 11 minus 5 is 6. 3 minus 2 is 1. See, as you can see, common factor. Now 16 times 5 is nothing but 80. I can move 16 outside, 41 plus 5 inside, so that I can cancel. So what is the answer? 5 plus root 41 or root 41 plus 5. You can use either 5 plus root 41 or square root of 41 plus 5. See, I'm telling square root of 41, square root of 7, square root of 2. So it's simply, let me show you that also. This is square root of 2. If no powers given here, it should be considered square root. What it is? Square root. But when there is number given like this, we call cubic root. So only condition, if they didn't give you any number here, it is understood it is square root of 2. Okay. So we finished this and this. This is very simple. So let me take you to number 4. That is square root of 40 over square root of 3. Again, we have only a rational number without any operators. I'm just taking the irrational denominator, multiplying by numerator and denominator. Root of 40 times root of 3 by root of 3, 3. So I can write 120 by 3. Now, number 5. Number 5 or 6, what can we do now? So yes, both sums we need to do. Okay, let me do number 5. 3 plus root 2 by 4 root 2 times, I told you to take only a rational number, not 4. Only square root of 2. See, to remember this, I'll show you, I'll give you a hint. See, our intention is to remove the irrational number in the denominator. See, nothing else. So consider removing the irrational number like square root of 2, square root of 41, square root of 3. So if there is no operator inside, just remember we are taking only a rational number, not the integers. I mean, whether it is 4 or other terms, you leave that. Now, 3 plus square root of 2 times square root of 2 by 4 root 2 times root 2. Now, let me do expanding using distributive law. Square root of 2, 3 plus root of 2 times root of 2 over 4 times 2, which is nothing but root of 2 times root of 2 is 2. 3 root 2 plus 2 over 8. That's all. Now I need to do number 6. This is the last sum. See, this is the variant. See, here only we had 4 root 2. Here instead we have operation inside. You should take 2 here and you should not take 4 here. That is the difference between both of the sums. Okay. Now a plus b the whole square and a square minus b square, which is a plus b into a minus b. So 2 plus root 3 the whole square would be a square plus 2 times a times b plus b square. I got 4 plus 4 root 3 plus 3, which is 7 plus 4 root 3. And for a square minus b square, we can simply write. So instead of 2 plus square root of 3 the whole square, I can write 7 plus 4 root 3 over 4 minus 3, which is 1, as the final answer I got. 7 plus 4 root 3. See, this is all about simplifying rational numbers and rationalizing the denominator. Okay. I hope you understood all about the simplifying and rationalizing the denominator in real numbers on this number system. So, thank you for watching until the end of this session on this real numbers. We will be back soon with more interesting lessons. Until then, keep learning with DhiNexus. Bye. This is Surya signing off.